In this video, we are going to learn about galvanic cell. At the end of this lesson, students should be able to define standard reduction or electrode potential Enode and standard cell potential Enode cell. Next, draw and explain the standard hydrogen electrode She and construct standard reduction or electrode potential series by using She. Standard reduction potentials can be defined as a measure of the ability of half cell to attract electrons towards it at 25 degrees Celsius, 1 atm pressure, and 1 molar concentration of electrolyte. The sign of Enode changes when the reaction is reversed, but changing the stoichiometric coefficients of a half cell reaction does not change the value of Enode. For example, we have Cl2 gas plus 2 electron produce 2 Cl minus aqueous. The Enode is positive 1.36 volt. If we multiply by 1/2, the Enode does not change. However, if we reverse the equation, the Enode becomes negative 1.36 volt. Now let's look at standard electrode potentials, Enode cell. There is a difference between E cell and Enode cell. E cell refers to maximum potential difference across a cell measured under non-standard conditions, also known as cell voltage, electromotive forces, or cell potential. However, if Enode cell is involved, the definition is maximum potential difference across a cell measured under standard condition at 25 degrees Celsius, 1 atm pressure, and 1 molar concentration of electrolyte. So the difference here is E cell is measured under non-standard conditions, while Enode cell is measured under standard condition. Let's proceed to see what is standard hydrogen electrode She. The standard reduction potential of the hydrogen electrode is defined as 0. The hydrogen electrode is called the standard hydrogen electrode She. We can use the She to measure the potentials of other kinds of electrodes. Let's see an experiment where She becomes cathode. In this experiment, She is paired up with zinc electrode. How do we know that in this experiment She becomes cathode? We study the observations. In this electrochemical cell with a zinc electrodes and a She, we can study the observation where zinc electrode becomes thinner or decrease in mass. This means that zinc is oxidized. The zinc solid dissolves into zinc 2+ and release 2 electrons. Therefore, the zinc electrode becomes the anode and undergo oxidations, while She becomes the cathode and undergo reduction. The 2H+ aqueous gain 2 electrons and reduce into H2 gas. We can write the half cell reactions at anode and cathode, including overall cell equations as follows. And the cell notation can be written as follows. Please note that at cathode, we add another single line and we write platinum, because in this case, we cannot use hydrogen as an electrode because it is a gas. So, we use an inert electrode such as PT to provide a surface for H plus to reduce into hydrogen gas. Now, let's look at an experiment where she becomes an anode. In this experiment, she is paired up with copper electrode. In this electrochemical cell with a copper electrodes and a she, we can know which one is anode and cathode by studying the observation. The copper electrode becomes thicker or increase in mass. This means that copper is reduced. The Cu2 plus from the solution gains 2 electrons and reduced into copper. So the copper electrode is cathode and undergoes reduction, while she becomes the anode and undergo oxidation. The H2 gas is oxidized into 2H plus and release 2 electrons. The half cells equations at anode and cathode and also the overall cell equations are as follows. The cell notation can be written as follows. Please note that we add PT electrode before we write the reactants at anode because, as we said before, hydrogens cannot be an electrode, so we use an inert electrode. The electrode reduction potential can be used to construct electrochemical series. The cells in the electrochemical series are arranged from the most positive E0 reduction value to the most negative E0 reduction value. The value of E0 reduction can be calculated from experiment with she by using the formula E0 cell equal E0 cathode minus E0 anode. So, what we have learned from the she experiment can be used to construct electrochemical series. For example, when she is paired up with zinc electrode, we can see the reading on the voltmeter, which is the E cell, is 0.76 volt. Considering the reaction happens at standard condition, the value of E cell is similar to the value of E0 cell. Since we know that zinc is the anode and she is the cathode, we can use the formula E0 cell equal E0 cathode minus E0 anode. The E0 cell is 0.76, the cathode is 0, and E0 anode is the value that we want to find. Hence, we will get the value for E0 anode, which refers to the zinc, as negative 0.76 volt. When the she is paired up with copper electrode, this time the voltmeter reading is 0.34 volt. Considering the reaction happens at standard condition, the value of E0 cell is also 0.34 volt. Now, here we know that the cathode is copper and the anode is hydrogen, the she electrode. So, we substitute the value E0 cell 0.34, E0 cathode is the value you want to find, E0 anode 0. So, we will get the value for E0 cathode, which refers to the copper, as positive 0.34 volt. The value of electrode reduction potential for zinc 2 plus /zinc, Cu2 plus /Cu, and H+/H2, we can rearrange them as shown in the electrochemical series, starting with copper, the most positive, followed by hydrogen, and last one is zinc. To prove this, we can see the electrochemical series attached with your lecture notes, and we can see that the copper is high above, the hydrogen is in the middle because the value is 0, and for zinc it is at the bottom of the electrochemical series. That's all for this video. Thank you.